Hey boys, welcome to the first video to do with our further motion calculations. Just going to run through it, and what I want you to do is follow through, and on your copy of this, which was on our sector lesson, I want you to copy and to basically do as I do, and we'll go through some examples a little bit later, and then you'll be asked to complete a number of them yourself. All right, so if we start with a simple explanation really, and if we have a look down at until now, it says we've solved problems using involving acceleration, speed and time. So when we look at our average velocity, or v bar, our average velocity, we said that was your final plus your initial divided by 2. We said that it's measured in meters per second, okay, and it's equal to that displacement on time. Remember, S was displacement. Displacement measured in, I'll just try and get that back up. Displacement measured in meters, and time obviously is t. We looked at our definition for acceleration as well, which we said was our change in velocity over change in time, which is v take u on t, and that's measured in meters per second per second. And we want to introduce to you 3 more powerful formulae that help us calculate not just time and distance, but speed, distance covered, and acceleration for something that's accelerated in a straight line. Okay, first one's easy because it's just tweaking what we've done before. So our v is our final velocity, as always. U is our initial velocity, and that a t there, okay, there's number of ways you can write it. A dot t, which is the same, of course, as a times t. Okay, and that comes from our definition of acceleration. V take u on t. All we've done is rearrange that and make final velocity our subject. If we want to, we can also tweak that, and we can say our initial velocity is v minus a t, acceleration times time. All right, our second one is a quadratic equation. You may notice, you may recognize that. Second one is a quadratic equation. And okay, first of all, S is our displacement, and rather than do that, I'll just highlight that. Our S is our displacement, is initial velocity times the time, plus a half acceleration times time squared. Now, a very useful tweak on that one, a rearrangement of that, is the fact that if our initial velocity is 0, then it just becomes, we can get rid of that, and we just say S is a half a t squared, or sometimes you'll see it written a times t squared on 2. Okay, now a little bit later on we'll come across a couple of examples where things are dropped in a gravitational field, and you just replace A by G. Okay, we've seen that before. So where the acceleration is 9.8, where you drop something, it's just A becomes 9.8. Okay. Our third equation is we don't have to worry about at this stage, but what it does is it comes from, it's from the fact of conservation of energy. It's from the fact that kinetic energy and potential energy are interchangeable, and the two, or basically the amount of energy remains constant in the system. So V squared is U squared plus 2AS. V is our final, U is our initial, A is our acceleration. Again, we can change it for G if we want. And S is our displacement. Okay. We will tweak that if we want to. And what we can say is, or U squared is equal to V squared minus 2AS. Or if we want to make our displacement the subject, V squared minus U squared all over 2A. Now don't be put off at this stage by those formulas. I've shown you the basic formula, but I've also shown you how we can rearrange them to make different variables the subject for each one. Now, let's make sure we remember, of course, what our variables are, and we need to remember that our S is our displacement, U is our initial velocity, V of course is our final velocity, A is our acceleration, and remember, if it's dropped, it becomes G, which of course is 9.8 in a gravitational field. Okay, and then of course T is our time, and it has to be measured in seconds. If it's in kilometers an hour or something, or if anything's in kilometers or hours, make sure you use those. You might remember those SI units. Okay, grab a calculator and we'll work through a couple of these. Pause and read the question and then come back. Okay, so you've read the question, and a really important thing in terms of setting out, guys, is we have to do what's called our SUVAT. You write down what you know and what you don't know. Okay, so if we go, our displacement, we said we don't know. Okay, our initial velocity, because it says from stationary, our initial velocity is 0 meters a second. Our final velocity was 40. What was this acceleration? And it took 7 seconds. So part A is really easy. We've seen this before. A is equal to V take U on T, which we said was 40, and initially it was 0, and it's over 7. So we got, I got 5.71 meters per second squared, and it's in the original direction. Okay, easy stuff. Now, part B. Using this information, how far has the car traveled during these 7 seconds? So we're still going back to our SUVAT. How far has it traveled? That's our displacement. So in this example here, we'll have S is U, T plus a half A T squared. Because it started with an initial velocity of 0, then you're going to have cancel that bit out there. So our displacement is a half AT squared. So it's a half 5.71, and then T squared is 49 because 7 squared is 49, and so in that time it would have traveled 142.1 meters. Now, part C. If it were to accelerate at this rate for another 90 seconds, how fast would it be going? So, A, V, take U on T. We need to be a little bit careful here, but we'll rearrange this. and we'll say that our final velocity is u plus at. Now, it was already going at 40 meters a second because it's another or further 90 seconds. Okay, plus it's going to continue at 5.71 meters a second and for another 90 seconds. So it's going to be going 553 meters per second. Okay, or in other words, if we times that by 3.6 and we get almost 2,000 kilometers an hour, which is insane. Okay, so that's the first example there. We'll go through another, perhaps another 2 or 3, and then we'll get you guys to do some more. All right, so question 2. Again, pause and read the question, and we'll meet back in a second. Cool, so again, what we've done, guys, is we've done our SUVAT. Right, we've worked out what we know and what we don't know on the left-hand side here. We do know our initial velocity. It was going at 25 meters per second. It rolls to a stop, so our final velocity is 0. And what we do know is it's decelerating at 2, so our acceleration is -2 meters per second squared. It's slowing down, obviously because of friction. And how long will that take? Well, we don't know just yet, do we? Okay, so yeah, question 2 is saying how long will it take. So if we go v is u plus at, which is our version of acceleration, so t is equal to v take u on a. Our final velocity was 0 because it stopped. Our initial velocity was 25. Our acceleration is negative. Okay, so it's going to take 12.5 seconds to stop. Notice the 2 negatives. Right. A negative over a negative makes a positive, so we know we're right. Okay. Question 3, how far will it roll in this time? Okay, so we want to find our displacement in this case. So if we go S is u t plus a half a t squared. Okay, need to be a little bit careful. Our initial velocity, it was going at 25, and our time for the motion was 12.5. Now, plus a half. Now the acceleration is negative. Be careful. -2 times 12.5 squared. Okay. Crunch that number in your calculator carefully, and we get 312.5. And because it's that negative number there, minus 156.25. So it's going to have traveled 156.25 meters along the ground in that original direction. So it's kind of going to go, if it's dropped from your car, it's kind of going to go boom, 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 and eventually come to a stop. And that's going to be about 156 meters by the time you've dropped it and hit the ground and it's stopped. Obviously, all right. Now, let's have a look at example 4, because it's about a ball being dropped from the ground. And straight away, our acceleration is negative, and it's 9.8 downwards. The question is asking you, how fast will it travel just as it hits the ground? Okay. It's 2 meters above the ground. We drop it from stationary, and we want to find its final velocity. Now, we can't use v is u plus at because we don't know how long it's in the air for. What we can use is v squared is u squared plus 2as. Remember, a becomes g. So v is the square root of Now, initial velocity was, well, the initial velocity was 0, so we can cancel that out. 2 times 9.8 times our displacement, square root of that, and it's going to be traveling at 6.26 meters a second. Now, we could do an experiment to actually verify that by dropping a ball from 2 meters, but unfortunately we can't. And unless you guys have got motion sensors at home, I don't think we'll be able to do that. If we looked at a velocity time graph of that, it'd probably look something like this. You know, if it dropped from 0, and I'll do sparkly because we can. You drop it from 0, bang. There's the initial velocity. So final velocity, when it hits the ground, it's going to be 6.26. Then, of course, it goes instantaneously or very quickly back to 0, and then it's going to go back up into the air again until it turns around, and each time it hits the ground, it's going to turn around. So here is where it's dropped from. Here is when it hits the ground. Here is when it hits the ground. The gradient of that graph is obviously going to be the acceleration, which is in this case 9.8 meters per second squared. All right. Now, what I might do is I'll pause it there, guys. I'll stop this one there. And for this lesson, I'd like you to have a look at these problems in our notes. And really, you should be able to do perhaps, I'd say, questions, probably questions 1 to 5 without too many issues. Question 1, the acceleration should be 15 meters per second. I'll get out of the rainbow colors. 15 meters per second squared. Part B, you should get 30 meters, and part C, you should get 10 seconds. Okay, because it says how long will it take. In other words, it's time. Okay. For the next couple, I won't give the answers straight off, but we'll go through them. If you've got any questions, you can come and ask me. So you can ask me via sector message. Our aim will be to finish those first 5, and then the next lesson we'll keep going from 6 onwards. Thanks, boys. Cheers.